Hey everyone, welcome back to the channel. In this video, I'm going to show you a technique to create meshes directly from drawings in Blender. This works for both digital art and 3D printing, so if you do stylized 3D, work with a hybrid workflow, or want to create organic shapes for print, this one's for you. This is all possible through a free add-on I made called Inkform. Link is in the description. About a year ago, I put out a video on the same topic, so converting 2D drawings to 3D meshes in Blender using grease pencil and geometry nodes. That video is still really useful, especially if you're thinking about animation or want an editable procedural setup. But over time, I wanted to implement some other features that could better support my workflow, and I wasn't able to achieve that cleanly with geometry nodes, so I built the add-on. Here, I'll walk through what I wanted to fix, what Inkform does, and how you can apply it to both digital and physical work. Let's get into it. For those who don't know me, my name is Kevin and I'm a digital artist. For the past few years, I've been working in stylized 2.5D and exploring other mediums like 3D printing. One of my primary tools is Blender, and specifically a feature inside of it called Grease Pencil. Grease Pencil lets you draw and animate 2D directly in 3D space. It was a complete game changer for me because before starting this channel, I primarily worked in 2D, and being able to combine both in one program opened up a lot of creative possibilities. It's native to Blender and integrates with all its other features, which means you can achieve styles you really couldn't get from just 2D or just 3D alone. If you want an intro to Grease Pencil, I have a jungle hut and a bakery tutorial on the channel. The bakery one is a bit older, but the fundamentals are still the same. I'm planning on an updated one for more recent versions of Blender. That said, from a technical standpoint, Grease Pencil objects are treated differently than mesh objects. There are things you can do to a mesh that you can't do to a Grease Pencil object, and vice versa. And sometimes in my workflow, I'd need to convert grease pencil strokes into actual mesh geometry, but that conversion wasn't always clean or intuitive. In general, I wanted something that supported both digital and 3D printing workflows, but more specifically, there were three things that I wanted to solve. The first was stroke radius. When you draw a grease pencil stroke with variable pressure, the thickness varies along the stroke naturally, but converting that into a mesh while actually retaining that variable thickness was something I could never cleanly achieve. I tried doing it with geometry nodes, but wasn't able to pull the per vertex radius data the way I needed. Now, there might be a way to do that I missed, but I couldn't get there. Inkform reads that data directly, so when you convert a stroke to a mesh tube, the thickness follows exactly how you drew it. The second was viewport flexibility. My geometry node setup was heavily dependent on the object's origin point, which made it awkward to use in practice. With Inkform, it converts the stroke wherever it is in the viewport, regardless of where the origin is positioned, which matters because grease pencil can be oriented in any direction in 3D space. The third was speed. I wanted to be able to draw, convert, and keep drawing without interrupting my flow. So I added a couple of things to support that. A button that prepares your scene for 3D printing by setting the correct unit scale and measurements, and a clear strokes button that removes your strokes and keeps you in draw mode, so you can keep building up geometry stroke by stroke without stopping to clean up naturally. Those three things were the core of it, and the rest of the add-on builds on top of that. Here's a full rundown of what it can do, and if you want to grab it, again, you can find the link in the description. At the top, we have Scene Setup. Set Scene for 3D printing automatically sets your unit scale to 0.001 and units to millimeters, which are the correct specifications for printing. If you're working digitally, you can leave it at default. For everything else, you'll need a grease pencil object in the scene. Also worth noting, for anyone new to grease pencil, there are two kinds of materials, strokes and fills, and all of the operators work with both. One thing to keep in mind before you start, make sure you're drawing on a keyframe, otherwise your strokes won't show up. Frame 1 works fine if you're just modeling. Right under that, we have clear strokes, which removes your strokes while keeping you in draw mode, so you can just keep going without having to go into edit mode and clean up manually. Stroke to mesh converts your grease pencil stroke into either a tube or ribbon mesh, reading the per vertex radius data directly, so the thickness follows exactly how you drew it. If tube is selected, it'll convert the stroke as is, and if ribbon is selected, it'll flatten the stroke along a specific axis with a thickness slider. It's great for branches, vines, cables or any kind of organic line work. Tube to remesh does the same conversion, but takes it a step further. Instead of leaving each stroke as a separate mesh, it merges and remeshes them all together into one unified piece. It's really useful for things like liquid or metallic Y2K style elements where you want everything to feel like one continuous form. Fill to plane converts a closed stroke into a flat filled mesh. You can set an extrude value to give it thickness right away, and it's great for leaves, petals, flat illustrated shapes, any outlined form you want as real geometry. The option below it does the same thing but with slightly cleaner geometry. Revolve takes a stroke and spins it around the 3D cursor along a specified axis like a lathe. Draw a profile and it generates the full 3D form. It's really useful for pots, vases, or bottles. Low step count gives you something faceted, and higher steps give you a smooth round result. You can also specify whether you want the top or bottom cap for vessels and set a wall thickness. Mirror converts a stroke and flips it along a specified axis. Like Revolve, it uses the 3D cursor as the pivot point. Path indent lets you indent directly onto the surface of a mesh with a stroke, so you can shift select the grease pencil object and then the mesh together in object mode, run the operation, and it Boolean cuts your stroke path into the surface, so you can draw detail onto an object and have it inset in. It's great for engraving, surface patterns, or adding organic texture to a 3D print. Cutout works similarly, but instead of indenting, it cuts all the way through. It's really useful for creating holes or negative space in things like pots or decorative panels. If you've seen my car ride stylized scene, most of the models in that scene were built using an earlier version of this add-on. So I needed a way to quickly model things like bricks and flowers, and being able to sketch them out with grease pencil and then convert them directly into geometry made the whole process a lot faster and more intuitive. So here I have a brick wall and a grease pencil object. Using surface stroke placement, I'm drawing directly onto the surface of the wall to create these rectangular brick shapes, then converting them into actual mesh geometry with Inkform. From there, I can apply a toon shader and adjust as needed. For the flowers, I drew the stem, converted that, and then created the petals separately, and was able to manipulate each mesh individually into the final shape. Another use case is for typography and graphic elements. If I want to add some organic drawn forms alongside text, I can sketch them out with grease pencil, convert them, and then apply whatever shader fits, so toon, metallic, or whatever the scene calls for. For 3D printing, you'll want to be a bit more careful when using these tools. First, make sure to hit Set Scene for 3D printing so you're working in the correct units from the start. So let's say I want to create a little pot. I'll draw a stroke to create the profile with grease pencil, and then I'll use Revolve with the step set to around 64 and the bottom capped. For wall thickness, 1.2 millimeters is the recommended minimum for 3D printing. That said, if you want more precise control over your dimensions before adding thickness, you can leave the wall thickness value at 0, then confirm the size manually. After, you can apply scale and add a solidify modifier with even thickness toggled. Once you're happy with the geometry, you can export it as an STL and bring it into whatever slicer you're using. One thing to keep in mind with any 3D print, you'll want to make sure your geometry is clean, so you don't have any major overhangs and the mesh is watertight. Inkform gets you a solid head start, but it's worth doing a quick check before you send it to print. Anyways, that's it for this video. Thank you so much for watching. I really appreciate it. Again, Inkform is a free download on my Gumroad and link is in the description. If you run into any issues or have any questions about the add-on or the workflow, you can feel free to drop them in the comments. If you want to support me, Theo, and the channel, you can also check out the shop at kevinram.com. And if this was helpful, liking the video and subscribing goes a long way. Thanks again, and I'll see you all in the next video.